Dear student, I am Dr. Harold Thomas, Professor in Applied Geology, Department of Applied Geology, Dr. Harish Singh Gaur Vishwavidyalaya, Sagar. Today, in this course, I will deliver my lecture on zeolite facies. I will cover this topic in two parts. In part 1, I will proceed under the following heads: introduction, characteristic minerals and mineral assemblages. Hope it will be useful for you. Regional metamorphism are the product of reaction in geosynclinal rocks of different protoliths at greater depth are compared to contact areoles. Such are rocks of the Barrovian zones of Scotland. The regional metamorphism are formed during orogenesis and therefore their formation is associated with plate tectonics and begins from burial or subduction to various depth. The different metamorphic facies are systematically shown in plate tectonic. See figure on screen. The rock of geolite facies are formed by burial metamorphism. The rock formation accumulating in geosynclinal basin gradually subside to greater depth where the temperature may be sufficient to bring about reaction between the minerals of the sediments and volcanics. The metamorphism set in at about 200 degrees centigrade. Below this temperature, mineral assemblages of low temperature sedimentary rocks undergo the process of diagenesis, during which recrystallization of minerals take place in sediments without any reaction to produce new set of minerals. When temperature is nearly 200 degrees centigrade or more, diagenesis merge into metamorphism. Few zeolite minerals, analcine NaAlSi2O6S2O, hollandite CaAl2Si7O18 6S2O, with quartz and adularia are also observed. The mafic rocks in diagenetic stage. With this background, we can describe the different metamorphic phases of regional metamorphism in the order of increasing temperature under intermediate pressure condition. First, zeolite facies and prehenite pumpelite facies. Second, greenschist facies. Third, amphibolite facies. Fourth, gammalite facies. If we move from zeolite to gammalite facies, usually pressure and temperature increase. The low grade regional metamorphic facies is zeolite facies. The zeolite facies was defined by Phi, Turner and Berrugan in 1958. The zeolite facies of rocks was first recognized by Clombs in 1954 from South Iceland, New Zealand, where the volcanic sand is metamorphosed at a depth of 20 to 30,000 feet. The lowest temperature of metamorphism is normally represented by zeolite facies and a higher pressure by glaucophene lawsonite facies, that is also known as blue schist facies. Important characteristic minerals are as follows: analcine NaAlSi2O6S2O, hollandite CaAlSi7O18 6S2O, lomentite CaAl2Si4O12 4S2O, prehenite Ca2Al3Si3O10 OS twice, pumpelite Ca4 MgFeMn, AlFeTi2, 5Si2O7, Si2 thrice O, OS 3.5. Lawsonite, CaAl2, Si2O7, OS twice S2O. Albite, NaAlSi3O8, quartz SiO2. Sedimentary minerals such as kaolinite and montmorillonite are still stable at this lowest temperature of metamorphism. The assemblages of the metavolcanics, volcanic sands and metagravex are as follows. On the basis of ACF diagram, hollandite, analcine, quartz with montmorillonite. Second, lawsonite / lomentite, quartz, chlorite. Third, adularia, albite, quartz. Fourth, lawsonite, lomentite, prehnite, quartz, chlorite. Fifth, prehnite, quartz, calcite, chlorite. Sixth, pumpelite, quartz, albite, chlorite. 7, prehnite, quartz, chlorite, albite, plus minus. 8, pumpelite, prehnite, quartz, plus minus albite. Let us see the ACF diagram on screen of zeolite facies when the temperature is less than 200 degrees centigrade, that is sedimentary environment. As per the diagram, A corner is occupied by kaolinite, F corner by magnesite and C corner occupied by calcite. From A to F is calcite, dolomite, magnesite, and from tie line between A to F is kaolinite, chlorite, magnesite. As per the diagram, if we look within the diagram, we can find out montmorillonite is the initial ACF diagram for purely sedimentary environment when temperature is less than 200 degrees centigrade. During zeolite facies metamorphism, sedimentary rocks like limestone and dolomite remain as such, and while clay minerals like kaolinite, hollandite and montmorillonite are also present. The metamorphic start in basic igneous rocks and gravex first metamorphosed. As per the diagram, ACF diagram of zeolite facies, when the temperature is less than 200 degrees centigrade, that is purely sedimentary environment, we can see the following assemblages: kaolinite, hollandite, calcite, dolomite, magnesite, chlorite and montmorillonite, etc. The first important change during metamorphism is formation of lomentite. Hollandite give rise to lomentite plus quartz, reaction number 2. This reaction is carried out by Nice in 1970 at 185 degrees centigrade 7 kilobar. Klump's in 1960 suggests that the first formation of lomentite coincide with the reaction analcine plus quartz give rise to albite, carried out by Campbell and Phi 1965 at 190 degrees centigrade at 1200 bars. Liu 1971 has also investigated this reaction and gave the forming data 200 degrees centigrade 2 kilobar, 183 degrees centigrade 5 kilobar. Lomentite give rise to lawsonite plus 2 quartz plus water, 200 degrees centigrade 2.8 kilobar and 250 degrees centigrade 3 kilobar. Crawford and Phi 1965, Nice 1971, Liu 1971. Thus, hollandite form lawsonite instead of lomentite when the pressure exceed more than 3 kilobar at slightly higher temperature than 200 degrees centigrade. For the reaction 1 and reaction 2, prehnite is formed via reaction number 4. Lomentite plus calcite give rise to prehnite plus quartz plus S2O plus CO2. This is followed by the formation of pumpelite through the reaction 5. Lomentite plus prehnite plus chlorite give rise to pumpelite plus quartz plus water. lawsonite plus quartz give rise to geosite plus pyrophyllite plus water, carried out by Crawford and Phi 1965, 400 degrees centigrade 6 kilobar and 225 degrees centigrade 7 kilobar. Pumpelite plus chlorite plus quartz give rise to clinogeosite plus actinolite plus S2O. Another reaction is pumpelite plus quartz give rise to prehenite plus clinogeosite plus chlorite plus water. Next reaction is prehenite plus chlorite plus quartz give rise to clinogeosite plus actinolite plus water. Nice 1971 investigated reaction 7 and also found the equilibrium temperature of 350 degrees centigrade 4 kilobar and 370 degrees centigrade 7 kilobar. Al2Si2O5 OH4 plus 2SiO2 give rise to Al2Si4O10 OH twice plus S2O, that is kaolinite plus quartz give rise to pyrophyllite. 345 degrees centigrade 2 kilobar, 375 degrees centigrade 4 kilobar, carried out by Thomson 1970. Thus, the disappearance of lawsonite, pumpelite, prehenite and kaolinite marks the upper temperature limit of the zeolite facies and also the lower temperature limit of greenschist facies, that is nearly 400 degrees centigrade. In this lecture, I will proceed under the following heads: PT condition during zeolite facies metamorphism and metamorphic reaction along with summary. Hope it will be useful for you. Try to be regular in course. The lower temperature limit of this facies has been proposed by the following reactions. Analcine plus quartz give rise to albite plus quartz, carried out by Campbell and Phi 1965, Loen 1971. Hollandite give rise to lomentite plus quartz, reaction 2, carried out by Nice 1968. The above reactions occur at temperature around 200 degrees centigrade. Lomentite give rise to lawsonite plus quartz plus water, 200 degrees centigrade 2.8 kilobar and 250 degrees centigrade 3 kilobar, carried out by Crawford and Phi 1965, Nice 1971, Loen 1971. Thus, hollandite form lawsonite instead of lomentite when the pressure exceed more than 3 kilobar at slightly higher temperature than 200 degrees centigrade. For the reaction 1 and 2, prehenite is formed via reaction number 4, that is lomentite plus calcite give rise to prehenite plus quartz plus water plus CO2. This is followed by the formation of pumpelite through the reaction 5, that is lomentite plus prehenite plus chlorite give rise to pumpelite plus quartz plus water. The upper temperature limit may be proposed by the following reaction. Lawsonite plus quartz give rise to geosite plus pyrophyllite plus water. This reaction was carried out by Crawford and Phi 1965. Pumpelite plus chlorite plus quartz give rise to clinogeosite plus actinolite plus water. Pumpelite plus quartz give rise to prehenite plus clinogeosite plus chlorite plus water. Prehenite plus chlorite plus quartz give rise to clinogeosite, actinolite plus water. This reaction was carried out by Nice 1971. Investigated reaction 7 is found the equilibrium temperature of 350 degrees centigrade 4 kilobar and 370 degrees centigrade 7 kilobar. Kaolinite plus quartz gave rise to pyrophyllite, reaction number 10, occur at 345 degrees centigrade 2 kilobar, 375 degrees centigrade 4 kilobar. The reaction carried out by Thomson 1970. Thus, the disappearance of lawsonite, pumpelite, prehenite and kaolinite marks the upper temperature limit of the zeolite facies and also the lower temperature limit of green cis facies, that is nearly 400 degrees centigrade. The upper pressure limit is given by the reaction NaAlSi3O8, that is albite give rise to jadeite plus SiO2, albite give rise to jadeite plus quartz, occur at 200 degrees centigrade 7.5 kilobar, 300 degrees centigrade 9.5 kilobar, carried out by Newton and Smith 1967. Another reaction is calcite give rise to aragonite, occur at 180 degrees centigrade 5 kilobar, 300 degrees centigrade 7 kilobar, 400 degrees centigrade 9 kilobar, carried out by Crawford and Phi 1964. Next reaction is chloride plus albite give rise to glaucophene plus water, that is reaction number 13, occur at 200 degrees centigrade 5 kilobar, 350 degrees centigrade 7 kilobar, carried out by Nice 1970. D. Rover 1972 gave 200 degrees centigrade 5 kilobar. These reaction 11, 12 and 13 suggest upper pressure limit of less than 8 kilobar, while the load pressure should be more than 3 to 4 kilobar in the temperature range of 200 to 400 degrees centigrade. The course content on metamorphic intermediate pressure phases begin with the introduction followed by the description of zeolite phases, the important characteristic minerals in this phases, metamorphic reaction, the chemographic phase relations with the help of ACF diagram and mineral assemblages, and finally the PT condition during zeolite phases, metamorphism. The temperature varies from 200 to 400 degrees centigrade and pressure should be 4 kilobar. For further studies, please read the textbook, references and links given in the text. Thank you very much. For further studies, please read the textbooks, references and links given in the text.